This video will demonstrate how to run external scripts using the command line in VisualPlate. Let's get started. In addition to using the command line directly, as shown in the previous video, more complex scripts can be generated in any text file and read into the program. This allows models to be easily generated, finite element meshes to be automatically refined, parametric studies to be performed, and much more. Note, when developing external scripts to run in VisualPlate, any valid C# code can be used, along with the commands that are already built into the program. The help file contains a couple of example scripts to help get us started running external scripts. Let's launch the help file and navigate to the external scripts page. We will begin by examining the simple model example. This example utilizes an external script to define and support a basic model, which is then analyzed to determine the maximum displacement. The model consists of a rectangular plate with pin supports on both the left and right sides, subject to a uniform pressure. The variables that define the model parameters shows that the model will be 12 inches high by 24 inches wide and will be a 1/4 inch thick. The material will be ASTM A36 steel, and 100 psf pressure will be applied to the boundary. 4 locations are defined, which are then used to add the boundary to the project. Next, the thickness is set and the material properties are assigned. The model is then supported on both its right and left sides, and a uniform pressure load is applied. Although mesh refinement is typically necessary to ensure the results converge, as demonstrated in the refined mesh script, this example sets the mesh defined for simplicity. The await analysis command is used to pause the script until the analysis is complete, allowing the maximum negative displacement to be obtained. Finally, this displacement value is printed. Now, let's type browse into the command line, navigate to the script file, which we've already saved on the desktop, and open it. The model is generated automatically, and after the analysis is complete, the maximum displacement is displayed. One advantage of using scripts to generate models is the ease of modifying parameters to create variations of the model. For example, we can change the width from 24 inches to 36 inches by simply updating the script. After adjusting the parameter, we can save the script file and reload it into the program. The new model, now 36 inches wide, is generated automatically. Once the analysis completes, we observe that the displacement has increased. This result makes sense because the updated model has a lower stiffness and is subject to more total load, leading to a greater displacement compared to the original model. Next, let's examine the refined mesh example script. This script uses a loop to refine the mesh of the simply supported plate example project until the extreme MY moment converges. The loop stops when the moment change is less than a specified tolerance of 0.001 kip inch per inch. Inside the while loop, the await analysis command is used to pause the script until the analysis is complete, allowing the maximum negative MY moment to be compared with the previous iteration's value. Now, let's open the simply supported plate example project for which we will refine the mesh. Having already saved the script in a text file, let's load it into the program by entering its path into the command line. As the script runs, the plate mesh becomes progressively finer, approaching a converged solution. In this case, the moment in the plate converges to 0.2587 kip inches per inch, with a final delta below the 0.001 kip inch per inch tolerance. It took 4 iterations for the model to converge. In just a few minutes, we've used the command line to run external scripts to define and support a simple model and refine a mesh to convergence. These examples just scratch the surface of what is possible with external scripts and VisualPlate. We hope you find this powerful new feature helpful and it enhances your productivity within the program. Thanks for watching and have a great day.